Well, now I want to talk about a function being even and odd. Okay, so what does it mean for a function to be even? Well, the definition is a function is even if f of minus x is the same thing as f of x. What does that mean? That means if I take the function f and I stick in minus x and I clean it up, I get the same thing that I started with. Let's look at a particular example. Our favorite little function, f of x is x squared. I want to claim that function is even. How would I prove that? Well, I'm going to take the function f, I'm going to stick in minus x into it. So what do I get? I get a minus x squared. Now minus x squared means what? Minus x times minus x. And if you think about a minus times a minus is a plus. So I end up with x squared, and guess what? That's where I started from. That's f. So f of minus x is the same as f of x. That's why we say this function is even. Notice that it's an even function, and guess what? That power is even. Interesting. All right, so what's nice about even functions? And the answer is every even function is symmetric with respect to the y-axis. We talked about symmetry last time with respect to the y-axis. And if I have an even function, then in fact I have symmetry with respect to the y-axis. You'll recall last time we looked at f of x equals x squared, and sure enough, it was symmetric with respect to the y-axis. Now let's look at another example. F of x equals x to the fourth plus x squared. I'm going to claim that also is an even function. Now, how would I prove that? The answer is I would go up here to my function f. Everywhere I see an x, I replace it with minus x. And see if I end up with the same thing that I started with. Well, if I plug in minus x, I get minus x to the fourth, add minus x squared. My rules of exponents would say that that's the same as what? Minus 1 to the fourth times x to the fourth, and minus 1 squared times x squared, or however which way you want to think about it, I end up with x to the fourth plus x squared, which, by the way, is exactly where I started. So f of minus x is, lo and behold, the same thing as f of x. That's what makes this function even. And again, I'm not sure what the picture looks like, but I'll tell you that it has to be symmetric with respect to what? The y-axis. All right. Well, I also have what I call odd functions. And y equals f of x is odd in case f of minus x is minus f of x. So I don't end up where I started, I end up with its negative. A particular example is f of x equals x cubed. Well, that's that one of those functions you should put in your back pocket. I claim that is a what? Odd function. How would I prove that? Well, I would take the function f, plug in minus x, and see what I get. I get a minus x all cubed, which is the same as a minus 1 cubed times x cubed. But minus 1 cubed is minus 1. So I get a minus x cubed. And notice f is x cubed. What's minus x cubed? It's minus f of x. So what have I just shown? That f of minus x is minus f of x, and that is what it means to be an odd function. An interesting tidbit is every odd function is symmetric with respect to the origin. And sure enough, if you recall last time, we talked about f of x equals x cubed, drew its little picture, and it is symmetric with respect to the origin. Now I'd like to make just one note. So we've given examples of an even function and an odd function, but the note I'd like to make is most functions are neither even nor odd. Most functions don't fit either one of those criteria. So unlike integers that are either even or odd, most functions are neither even nor odd. And if you'd like an example of such a function, look at f of x equals x squared plus x, and I claim that it's neither even nor odd. And my argument would be, if I were to take f and stick in minus x, I would get a what? Minus x squared plus a minus x. And when I simplified that, I would get what? X squared subtract x. Because minus x all squared is just x squared. You will notice that that is not f of x, because why? F of x is x squared plus x, and this is x squared minus x. So it's not f of x, hence it's not even. And it's not minus f of x, because minus f of x would be what? Minus x squared plus x, which is minus x squared minus x. And notice that this is not this. Right? So I can say, hence, it's also not odd. So be warned that most functions are neither even nor odd. And I'll stop there.